Hi, everyone. Thank you so much for joining us today. As some of you know, I am Paola and I am the Director of Medical Research here at Micron. My background is that I'm a medical doctor, but also a computer engineer, and I have been working for a while now and kind of building that overlap and closing that gap between healthcare and technology. So, very excited to have you all here. We'll be doing a masterclass on how agentic AI is helping shape healthcare. We'll be diving deep into how the whole process happens when we're training a model. Because it's very interesting to see the final result on what's out there, what you guys interact with. So today we're going to be doing a deeper dive on what happens behind the scene to make that data and information accessible to everyone. I'll hand it over to my colleague, Dr. Cahill, that will be
Mhm.
taking it from here.
Hi there, everyone. Thanks for joining us. My name is Dr. Cahill. I'm a strategic project lead here at Micro One. I've been involved in various healthcare innovation projects at Boston Children's Hospital in their Innovation and Digital Health Accelerator, especially regarding virtual visits and scaling their telemedicine program enterprise-wide. I worked in the Department of Urology on some clinical research projects as well at Boston Children's Hospital. Then I completed my clinical training, earning my MD at Harvard Medical School, and had some brief exposure to healthcare operations and management before joining the team here at Micro One. And it's been really exciting being part of this all-star team, not only our core team, but also many of you on the call, I'm sure, are expert annotators. I'm looking forward to our conversation today. Great. So I'll kick it off here by starting with just where standard evaluation falls short in the life sciences. And then we'll kind of get into some of the failure modes and the way that we design tasks and stuff going forward. So for starters, there's really maybe three main places that it could fall short: domain-specific failure modes, evaluation as a one-time event, and findings without a feedback loop. And so, in the context of model development and agentic development and evaluation, what this looks like is if you kind of understand how models were formed, mostly they were trained on all the data available on the internet. And now we're at the point where to meaningfully advance these models, we need human expertise, which at Micro One, more and more we're referring to as units of intelligence. And so we're able to source and vet experts across domains. So subspecialists, think like pathologists or neonatologists, and work with them to define what should tasks look like and what are important failure modes in their domain, in their day-to-day workflows. And so that's really that first point. And then evaluation as a one-time event. I think this is very central for anything in AI training and really takes a couple of forms. One is that just like clinical training for humans is not a one-time event, you don't just get licensed to practice and then there's no follow-through. It's a continuous and iterative process. Same thing, the models needs to be continuously improved. And I've even read recently that there's as many as 1 to 3 million life science papers published every single year, a significant portion of which are in healthcare and in the medical space. And all of that needs to be fed into the models so that the models need to advance with the guidelines, with the cutting edge of medical research. And besides that, the models themselves change over time. And that also kind of feeds forward into this last point of the feedback loop, where as the models are improved, some of the parameters are changed, there is potential for drift, and that needs to be accounted for and that needs to be improved. And so, especially for any sort of a AI agent in a healthcare space, it's really like a long-standing iterative process.
Amazing. Thank you, Dylan. I'd love to touch a little base on what you said, which is the domain and specific failure modes. I think this is one of the most important things to discuss, especially when it comes to healthcare, because well, we've discussed this before. If you are providing any kind of medical advice that is user facing, you're inherently participating in care, right? So it's very important to know what really we're looking for when we call something a failure, okay? It's not always only in the output. We actually released a benchmark not long ago that was about specifically this. What kind of failure modes you can find that go a little bit deeper than the final output. So here's an example, for example, where we had pathology reports taken from an specimen of a biopsy from the stomach tissue, right? And this patient had bacteria in the tissue. It was found, which was H. pylori. It is very common that this bacteria causes gastritis, a lot of uncomfortable symptoms, vomiting, pain, and so on. And the model not only detect or well explain the presence of the bacteria within the report, but it also went ahead and provided therapy and medication for it. So basically, the final treatment that the user should follow. But these treatments are mostly it's a case by case basis, right? We should always respect all other aspects of the patient before providing a therapy procedure after seeing a diagnosis. So a model just providing therapy and telling the user what kind of medication they should be taking by seeing the pathology report when it was specified the kind of output that we're desiring, which was only the diagnosis would be considered clinical overreach. And this is a very, very common failure mode for healthcare within AI models nowadays. And of course, it's not only unsafe, but we need to be very careful about it because not all the time is the same treatment for everyone. So it could turn out to be a little bit harmful for the patient. Another one that is also very common is unsupported inference. So models don't really know how to handle uncertainty as much as they should. Even us doctors, when we get a patient in the ER and they provide us a pathology report or the results from a lab report of any kind, could be a hemogram or could be any other kind of reporting, and we're not sure whether that describes the full picture, we manage uncertainty, saying that either we need additional supporting criteria, that we need more examination, that we need to see the patient further, that we need other kinds of reports to happen before we reach a final diagnosis. Well, the model should also proceed with that caution when needed. But it is very common that the models don't do this, but they fill in the spaces. They fill in the gaps themselves by making assumptions. We shouldn't do this with patients or with clinical data because not always filling the gap with what is common as it would work with other domains, let's say finance, for example, might work there because you're filling the gaps with already known information and you're just being helpful by providing a final outcome to the user, right? But sometimes if the specimen that you're looking at is not enough proof to provide a final diagnosis, then the best thing here is the hedging and also managing uncertainty and being able to identify that you do not have enough supporting evidence to reach a clinical conclusion. So it's another failure mode that it's, I'd say, very specific to healthcare. I don't think it applies to multiple domains for sure, because most of them, when you do fill out the gaps, it's very standard information and you're actually just being helpful and doing a good job at it. In healthcare, it's where this would be considered a failure mode rather than a reward.
Excellent. And yeah, building off that, I also kind of just want to add to this conversation how it's interesting. Paola and I were having a discussion just this past week looking at various medical benchmarks and seeing the rate of improvement with these models. And yet at the same time, we kind of touched upon how there's this dichotomy with as advanced as the models are, we have this intuitive sense that they're not ready for clinical deployment in most cases. And especially those of you who are on this call who may be physicians, you probably know that there are great tools that you could have, in your pocket, on your phone. Maybe they're integrated into the EHR system you're working towards, but they're tools. They can't really, take over patient care end to end. There's a lot of nuance involved. There's a lot of context that we've accumulated through our careers. And still, a lot of that can be used to train models. And so that can even kind of bring it into what we're discussing here now is thinking to get these more clinic ready and allow them to be a little bit more autonomous and own workflows end to end rather than just be a chatbot tool. There's important considerations that go into setting up these data pipelines and how we capture and evaluate it. And so for example, building the framework, we want to start with this success metric definition. So, like we said, that's going to be done like a two-way street with our in-house medical experts, but also any annotators that have specific subdomain expertise to determine, what are the important failure modes? What are some of the edge cases? What does that look like? How is accuracy defined? What are these safe behavior boundaries that we should be looking at? What are the high risk categories that we should be keying in on with the portion of the data set? And then there's different frameworks for collecting data and for developing these data sets. One of the most common that some of you who have been involved in data annotation probably have exposure to is rubrics, where we define like each of these criteria of this is something the model should have said, this is something it should not have said, and we can build into that various structure too. We can add categorization, we can add weighting, things that the model should be rewarded for doing or penalized for doing, and we can calibrate it accordingly. For example, in a healthcare setting, things that would be explicitly dangerous can have a higher degree of model punishment. And then the taxonomy of the failure modes is something that we can also specifically look at, and it can help us determine, where the model's failing. And so, which step? Is it the reasoning itself? Is it that it's falling short in certain domains or subdomains? Is it certain risk levels where it's not properly allocating, for example, treatments for the highest risk individuals? Perhaps that's where its data training set has been more limited, and so we can add more there. And all of that is really pre-project, part of this evaluation set design, curating representative sets that model real workflows. And this is, I think, one of the interesting slides that really gets into kind of where we are at with agents and kind of the difference between training a model and training an agent. And there's a few different ways you can think of this, but an agent is really tends to be something that has a little bit more autonomy to take multiple steps. And so again, we're long past the simple days of, is this a dog or is this a cat? And we're also largely past the does this output sound better than this output? Is the length and structure. The chatbots have gotten very, very good at that based on so many data points. And so in medicine, it's also about accuracy. Yes. So we still do some of that, which one of these seems more authentic to how a licensed physician, for example, might respond to a query that a user would make. But more and more, we want to add complexity that mimics real workflows. So part of that is multi-turn, meaning multiple iterations of inputs to the model. So like a conversation that has 3 or 4 separate inputs, and the model needs to take that into account without losing prior context when determining a final output. Just like, again, physicians have to do every day, from getting some, prior sense of what this patient case might be about, taking a history, then reviewing new lab reports as they come in. This is the way that we're now more and more training models. And we can also apply this in different ways. We can still add comparative rankings, and we can still we can also build into it specific cases that are meant to test the limits of its knowledge. And so we could almost add test cases to try to get the model to fail. The goal isn't to make the model fail per se, but it's to test where we think it may be limited so that we can create more data and improve it right there. And lastly, a general theme in all of this, as we add complexity, we make it longer horizon, we add different modalities like images and stuff, is we want to look not just at the final output, but the reasoning path it took to get there. And so this is something that you can actually apply the same frameworks towards. So for example, the models will actually have their exact thought process of what they were thinking at each step, and what tools they decided to call, what inputs they decided to value. And a human could decide, does that mimic the way they would think about it? Or is it picking up on the wrong details, or is it omitting things? And so we can create rubrics around all of that. And so this is kind of just putting it together. So how do we take these evaluation findings to model improvement? Well, it all kind of feeds together. So we have these expert calibrated evaluation against real workflows and success criteria. So this again captures how do we develop the tasks, and that feeds into these structured failure reporting, the frequency, the root cause, the risk level, the addressability. And so we can kind of categorize the tasks and the expected failures and the observed failures. We can then turn this into the targeted training data, and we can also create golden responses. And so after one of these multi-turn conversations, the expected output would be our golden response. So we can create rubrics around that, what must be included, what must not be included. That can then be used to directly improve the models. And we can fine tune it from there. We can adjust the workflow. Anyone who's been involved in really any human data project probably knows that this is very much an iterative process, not just training the model, but also realizing in real time what are the important signals, what are the important metrics that should be adjusted, so that we can make sure that we're supplying the best data possible. So often need to be flexible, adaptable, and really observe the data as it's coming in. And then and then again, once you feed that into the model, then you want to see, is it improving? Because that's really the final step with whether it's model improvement or agent improvements is this structured assessment actually helping it to achieve new accuracy and reliability ratings? And so you want to track that performance longitudinally as it's being updated. And so to achieve all of this is where our experts and annotator pool comes into play. And I think that's somewhere that we really shine here at Micro One. And don't really want to take too much credit myself. It's really you all who participate in our AI training projects that gives us that competitive edge and allows us to create some of the most robust data sets that earn the trust of leading frontier labs as well as like major enterprises. And so, for example, if we are kicking off an imaging pipeline, we can source not only pathologists and radiologists, but also those with board specialization, fellowship training in specific subdomains, and we can use their input to create specific tasks, specific types, and really challenge the model at the limits of its ability. And this is something that we are doing routinely more and more. And we're moving towards protocol-driven work. And so this kind of, again, echoes a theme that we've already been discussing, where we really want this to mimic real day-to-day workflows. We want these to not just be a tool that you can, search on the side alongside to kind of get reassurance with your approach, but something that can actually play a role embedded into the workflow and really enable you to do even more with a higher degree of accuracy. And this comes also into the structure and of the data. And so in healthcare, a lot of the data is very unstructured and scattered, and the models are getting better at interpreting this, but it still helps to get it started by structuring, what are the important elements and how can the model ingest this so that it can improve over time. And you can also, apply specific labels so it understands, what are the important data types for different cases, for different questions. And then that becomes part of the training as well. Like, is it pulling in the important documents, the important inputs, and is it referring to the specific sections that are, most relevant for safe outcomes? Looks like you're muted, Paula, but I'll let you take it
Sorry.
over here for this case study, which was great.
Amazing. Thank you, Dylan. So, yes, I love when we discuss all of the steps that we usually take and how this evaluation behind the scenes happen before we actually kick off a pipeline and we go into all of this model training process. So, we brought today here a case study to discuss where all of the things that Dylan discussed on how our way of thinking, how we proceed, how we source the experts and everything, how they all come into play to actually get a final result of, well, of course, model improvement. So here, for example, we have a drug-induced liver injury detection system, okay, where we went from annotations to model improvement. The challenge came to us from a client where they had all of these huge data set that they wanted to run evaluations on. The data set consisted on images, well, slides, pathology slides of tissue of drug-induced liver injuries, right? And the idea was to try and annotate these images to improve the way that these are detected, kind of like building a predictive algorithm. So this task demanded not only genuine pathology expertise, but also the right structure and how the data was going to look like, how we're going to architect the data. So when the model ingested, it actually can improve and not only pattern identification, which is one of the neural networking, kind of like one of the most common pattern identification for model training. So we did not only the image classification, but we also had to take into consideration the clinical reasoning that was grounded in the tissue analysis that came from each type of injury pattern, which we had four categories that are kind of like the most common, or well, I would say the biggest ones from this type of injuries, which are whether the cell was steatotic, cholestatic, cytotoxic, or mixed, whether it had two or more of these variations all together. So we had all of these challenge. Then we went into the thought process. Okay, how can we actually design this in a way that it makes sense? So we built a very structured evaluation framework from scratch to kind of improve the way that the model interpreted these images. So, as Dylan was saying, one of the first steps is define what is success. Okay, what would be the successful criteria for a model that is image predominant would interpret or would generate interpretations across all of the four injury categories that we had from a clinical reasoning perspective and make this objectively gradable so the model can also replicate it and learn from it, right? So, we evaluated that we need to include a clinical reasoning rubric to make it objectively gradable, of course, that could assess morphological variations or observations directly within the image. A differential consideration as well. We might have to include an image of what we would call healthy liver cell versus a drug-induced injury one. So we could also match what would be the differences and the main patterns to look for. And then the diagnostic justification as to why it's, making this category or calling on this kind of injury level for the tissue. So then, after building this pipeline, we went into sourcing. We already knew within the challenge evaluation that we needed very, very good expert pathologists to participate in this pipeline. And then we evaluate the design, we architecture the data structure, and we went into how are we going to put this in place? How are we going to run it? So we said, okay, so we have the objectable, gradable criteria with the rubrics. We have the image annotation to kind of anchor down what would be the differences. How can we improve the clinical reasoning behind it as well? Because it is very common uncertainty once again. We didn't want unsupported inference to happen within the model. So what we did was that every slide was evaluated twice by two different experts. So that way we could handle uncertainty better. So we did dual expert reviews on every task. So we could calibrate the rubrics and the criteria that we were getting for each of these images to make it as a signal whether something, a pattern could induce a lot of uncertainty and how could this be better handled? What would be the best percentage of result or statistically which one should be more robustly identified. And then that's when we had the final results. So what we found was that the expert evaluation surfaced any kind of systematic gaps that could be done by only pattern identification or gradably induced rubrics, right? These two expert evaluation help us reduce the uncertainty on how to best manage it so we could reduce the fake positives that were coming as a final output. So the model performed well on canonical injury presentations and cases, of course, but also on those where hedging was more notorious and where we didn't know for sure before whether it was mixed or it was only one of the injury types. All in all, the finding was detectable by evaluators with direct histopathological knowledge that help make the model improve, help the clinical reasoning behind it, all of the trajectory of the evaluation and not just the final output, and finally gave us a better result on how the model, well, responded to each of these slides for the drug-induced liver injuries. So in here, we're just applying the whole flow on what Dylan discussed and how at the end it gives us safer and more accurate results.
And I want to yeah just build on and highlight one point there, which was around like the dual expert review. Adding multiple layers of either to the review or even initial task layer is helpful. As one of the prior slides I mentioned, but didn't really speak to yet, this inter-rater agreement can be very valuable. Just like if you were like designing a test for students and you find that there's a small subset of responses that a lot of the students are getting wrong, that's worth keying in on. Is it because the question is designed poorly, or is it that the class wasn't educated on that topic properly, or is it actually a great assessment and it's really differentiating the top students from the ones who haven't studied as much. The same thing applies. Is it a properly designed task, and is this something that is actually, if it is properly designed, maybe the disagreement between annotators means that it's actually testing at the limit of the model's knowledge as well. And so we can, key in on that. Otherwise, in general, inter-rater agreement also helps us have a greater degree of confidence that when we do have high rates of agreement, that, obviously it's more likely accurate and more robust data set for model training. But that's just one of many levers that I wanted to emphasize of ways that, we can kind of fine tune and finally calibrate these data sets.
Thank you, Dylan. So the key takeaway on all of this and all of these calibration processes and the final outputs and all of these deep evaluations we do on the on the agentic trajectory of model interpretation for each output is that domain experts should be embedded at every single stage. So when we had the pre-project, which is basically being face to face to the actual challenge, we were already imagining what kind of profile would help us best define with human intelligence on how to best improve the challenge and finally solve it. And then in the in project, when we're actually building the data, the data and structuring the data architecture for the desired success definition, we of course have deep involvement of the human expertise throughout the whole process, and that's the main input that we feed into the model. And then the post project, when we already went through all of this training, we had all of these findings, we strategically summarize all of the findings into actual failure reports so we can prioritize what comes next, what are we looking into, what would be the main failure mode that this model is facing, so we can go all over again to the first stage of the pipeline, which is the pre-project. Now we have this challenge, what kind of expertise would help us solve it? Then we go in, put the input data, which would be the human expertise, and then once again we run it and have the findings that will help us define what comes after. All of this could look very differently depending on the challenge that we're facing, okay? We have multiple forms of data types and annotation modalities. So we have the single prompt grading. This is very common when it's kind of like a user prompt versus a response. Very similar to if you interact with, let's say, a chatbot and you ask them something very specific, like tell me the best way to treat a cold, right? And the model is going to give you a response on this, okay? You just grab that response and you grade it objectively. This could be with Likert scorings, this could be with rubrics, this could be with a golden response that is also a data type. So you just overlap these two to grade how well the model did or how much it failed. It's um, very frequently used also in the medical domain in healthcare, but I'd say it's not the preferred one for all of the subdomains that there are in medical specialty. I'd say it's the most common for user-facing models. So we have the multi-turn conversations, very similar to the simple prompt grading, but you're evaluating all of it. You're not only evaluating the final response that the model gives, but how the model leads the conversation. So the prompt, still the same. The user asks a question and says something to the model, and the way that the model diverts this question to start offering responses or maybe get to a final diagnosis or a clinical outreach, then you're grading all of that, all of the steps that the model is taking to reach to the final step of the conversation. This could be graded once again, could be rubrics, Likert, golden response comparison, or there's so many grading methods, just to say a few that we have already discussed, but it's just this kind of data type. Image annotation, I'd say it's very common in the medical domain. We actually did a project like this one not long ago with Dylan. It's very common, for example, in X-rays, right? So an image annotation is where you identify a finding right directly within the image itself. This is translated into pixels and pattern recognition. So let's say that you want to identify or a model to be able to identify a type of fracture, okay? Even if it's in different bones. So you provide different X-rays with that same type of fracture, and you have a lot of experts. In this case could be orthopedic surgeons or ER doctors, and they just go in and through a bounding box highlight the fracture and name it so that the model can ingest that information and be able to identify the fracture in other places or other positions of x-rays, right? So that is one example. PDF and document grading, also very common for healthcare domain because, for example, every time you guys ask about results or interpretation for a lab report, that has to do with PDF and document grading. These ones again could also be overlapped with the single prompt grading, the multi-turn conversation. I'd say that this doesn't mean they're all exclusively that if you have one, you can have the other. It's not an either or situation. You can have different or multiple types of data and multiple types of annotation within the same task and within the same pipeline, and that's still okay. You just need to identify which kind of types of data you'll have so that you can best decide, well, the way that you're going to grade it. Then we have the golden responses. This is very, very good for human intelligence because it's basically we have the experts write down what they believe would be the best response, clinically speaking, for the question that the user asks. Okay, so we can objectively grade that golden response against what the model actually produced, and we can either penalize it for missing key things or reward it if it's close enough to the golden response. And then contrastive pairs, which is what we're discussing. Sometimes we have closely matched examples where the clinical differences are very subtle, and we need to teach the models to handle uncertainty. So we have different pairs of experts working on the same task to see a broader perspective on how we could tackle this down.
Yeah, I'll just briefly add that I think one thing that makes this industry, this space is exciting is that if we have the same conversation 6 months from now, this slide will likely look very different. We'll still be needing all these same inputs because these are true to what we're using today, but there will likely be new categories and new task structures developed, and that's just a function of how fast the models are improving. And I even remember on one of these data pipelines I was a part of, we were trying to stump the model in different ways, and one of the physicians I was working with, was tried to give it a very, very hard question, like a very rare diagnosis, explained in vague terms, just like you might see in the clinic. And no matter how he framed it, got it right every time. And it really kind of came to the conclusion that a lot of these models are like savant clinicians. And I think that speaks to how we now have to, really step up to how do we actually push their intelligence? Because again, they're very good at the very clear cases. They're very good at even the rare cases, anything that's well defined in a textbook or that might be assessed on a board exam. But as we know, that's not necessarily what clinical workflows look like. And just arriving at a diagnosis on a multiple choice test isn't very real world like either. Even just knowing what questions to ask, right, and what information to gather next, for treatment planning, all of that is valuable. And so all of that reflects an opportunity to create new task structures and types and reinvent the way that we're assessing and improving the models. And so that's something I also invite anyone listening to be thinking about too in your day-to-day workflow of what might an improved task look like that more closely mimics your workflows, because we're really at the cutting edge of this industry that's evolving so fast, and I think we'll continue to see exciting changes.
Exactly, and that takes us to what really is Micron's involvement in making all of this amazing magic happen. So, as we learn from this whole conversation, human intelligence, it is a key and I would say a foundation of all of these model training initiatives that are happening, and the only way that a model can actually improve. So, Micron has a network of over 200,000 active physicians. So basically, thanks of all of this intelligence that we have within our network, we're able to make this happen. Um, I'll basic all of you. It's a shout out to all of our amazing experts. Without their human intelligence, I'd say many of the actual technological improvements that we're seeing nowadays would not be possible. So we have over 200,000 verified physicians that have actively participated in multiple of these training initiatives. This whole process from identification the challenge to getting the experts onboarded to a pipeline could take up to 48 hours. So it's just very straightforward. And the most important thing of having a very big network is that we have basically every single clinical specialty that there is, because it's not the same for, let's say, X-ray interpretation than if you're looking into pathology lab reports, or if you're looking for very specific hemograms or cancer images. So all of this is only possible because we have people with human intelligence making it possible here. And of course, global coverage, because it's never the same to have people globally available than just from one specific location. Not only knowledge is distributed differently, but it also helps us make all of these make all of this information more accessible.
Wonderful. Thanks so much for closing out the main discussion here. We have a few questions which we can get into. I can kick off the first one, which was about adversarial probing and kind of testing these failure modes. And there was a question about regional epidemiology, like a symptom pattern that's a clear red flag in a dengue endemic area that wouldn't stand out elsewhere. And so, how is that local context built into the eval set? And I think this is a fantastic question. This is really like to the point I was speaking to a moment ago, where the models are very advanced. It's evolving rapidly, and so like, what is sort of the next frontier? And this is something that's actively developing. It's not just one of the emphasis of this talk was domain expertise, but really what this question alludes to is that there's also other considerations like regional considerations and variation, and the way medicine is practiced in different areas. Sure, it might adhere to the same gold standard, but there's going to be different frequency, different indices, incidence and prevalence of diseases that must be accounted for that like truly impacts diagnostic and treatment decisions. And so there's a few ways. And for one, this is something that the leading labs are definitely mindful of. And so they're asking us to source more and more niche experts in those regions so that we could have their context. And then, as we were saying before, a lot of this really goes into the pre-pipeline kickoff planning, where we will engage some of those experts to help define, what are the ways that the tasks should be structured. So, for example, simply adding a tag, a field for location, and having that be part of it already allows you to subset the data set and then allow it to behave differently. And then I think it also translates into that point of post-deployment monitoring. The same model, if you assess it in different contexts, might lead to different results. It might have a higher degree of accuracy in some areas than others. And so really what you need is to start to have subspecialized models that are specific to different regions, at least as it relates to this question. Already, one thing that is being observed, especially if you start to look at some of these recently released medical benchmarks, is that the generalist models are definitely improving in their diagnostic and medical capabilities, but we're also seeing some of the fastest improvements and like highest scores from those that are domain specific. So those that are specifically built to answer healthcare questions. And so I think you can take that down many levels and say not only something domain specific, but also that, has that regional sensitivity is also something that can lead to, a higher degree of accuracy, reliability, and overall quality.
Great. Thank you, Dylan. Um, we also have this other question, which says, as healthcare AI evolves, what opportunities exist for doctors and clinical experts to contribute beyond data annotation, such as in AI evaluation, safety testing, workflow validation, and clinical reasoning? I love this question because it has definitely been part of what we has discussed. It's not only about the input data or the direct annotation what matters in all of these workflows, but especially in healthcare, it's on how the trajectories modify the way that the output is reached. Sometimes the output is correct, but the clinical reasoning behind it is not. So here's when human intelligence will always be relevant. We always will have reviewing processes where we have to detail what went wrong in the clinical reasoning or what was missing or what could have been added to ensure that every single response that is offered to the final user is always safe, unharmful, and accurate as possible. Without, of course, falling into one of the failure modes, clinical overreach or unsupported evidence, which is one of the output. The final output might be correct, but the way that it got there, it's not, which means filling in the gaps with assumptions, which is not always safe to do in clinical context. So human expertise and human intelligence will always be relevant to every single step of the whole workflow. Just like you said, could be safety testing and also trying to break the models. So how can you manipulate the model to give you a harmful response, for example? That's definitely one reason where maybe the trainers can. It's very hard to evaluate objectively something that you worked on, right? So we will always need expert knowledge to come in here with a fresh pair of eyes, looking at the model and trying to break it. How can I manipulate you to give me the harmful response that I want? Right? That is some sort of safety testing that is deeply in need of human expertise as well. I'd say that as AI evolves, it's only doing so because the human intelligence is allowing it to get there. So it's there's always this synergy, right? All of the concepts in AI come from trying to simulate biology, physiology, how the human body works, how our brains think, how we reach to conclusions, how we create patterns. So AI is evolving because we're allowing it to evolve that way. So with this, what I'm trying to say is one cannot exist without the other. There will always be a need for human intelligence for models to exist, and this goes way beyond just data annotation. All of the steps of the way to make a model ingest data and train from it are deeply closely aligned with the human expertise that goes with it.
Thank you for that. And yeah, this also answers one of the more recent questions that I think is interesting. This point about a human in the loop. And I agree. I think it's changing a bit over time where the way the human is kept in the loop and the way that physicians, for example, are providing their expertise, that is changing a little bit and may continue to change. And for example, there may become more of a synthetic component where the model is actually starting to suggest ways to improve itself. And then the humans, the physicians are coming in and are deciding, is this correct? For example, a synthetically generated rubric. Do these criteria make sense? And what should be manipulated? What can be added or subtracted? And so that's part of it. The other is sometimes at the beginning of like a new medical school class, the dean will say something like, only 50% of what we're about to teach you is accurate and the other 50% is wrong. The problem is we just don't know which half is which. And I think to some extent that'll always be true in medicine is that, we're always evolving and the knowledge is always increasing. So it's not really logical to think we'll just like reach a state where we have the knowledge and the model is, like has achieved a gold standard that can't be improved. We humans will always be driving that improvement, but it'll be more on that like that edge frontier where the humans are applying that expertise, making sure that the latest literature is being, incorporated correctly, and that, when we're applying this in clinical settings, because what we're discussing today touches real people, real humans, is it achieving the outcomes? And so perhaps longitudinally, not just is the answer correct, but is the treatment protocol that the model suggested correct, and how does that impact the overall patient care, and feed that back into the model. So a lot of really exciting potential ahead here.
Amazing. I absolutely agree. Just like Dylan said, there is a saying, medicine that is 2 plus 2 is rarely ever 4. And the only way that we can actually get to good results for, of course, facing users and facing users of these models is to have a human in the loop that can keep open-minded and give broader perspective always. It's mostly a case by case basis. And we're at a time, people. Thank you so much, everyone, for joining us. Thank you, Dylan, for, of course, taking participation here in this masterclass. It's been amazing. Of course, we can keep taking on questions via Slack as always. We're very happy to everyone who made it and hope to see you soon in the next one.
Thank you all.
Thank you so much, everyone.